Okay, in this question we have a ripple tank. This is the waves required practical, and here we've got the ripple tank set up on a bench. We've got some water, we've got a motor and a lamp, and the white card with the waves all projected below it. So for part A, the motor makes a noise when it is turned on. And the question says, describe the differences between the properties of the sound waves produced by the motor and the water waves in the ripple tank. And this is worth 4 marks. So we've got to make at least 4 distinct points. The first thing we could say is we could say the sound waves are longitudinal. Pen's running out. And we can then say for a second mark, this means they oscillate in the direction of travel. So when we say oscillate, we mean a motion that repeats itself. And if a sound wave is traveling in one way, the oscillation will go in the same way, backwards and forwards. This is the technical language you need to use. Okay, that would be worth 2 marks because we said what kind of wave it is and what direction it oscillates in. Next we can say the water wave is a transverse wave. And once again, we're going to say what direction they oscillate in. In this case, for a transverse wave, we're going to say this means they oscillate perpendicular to the direction of travel. Now, we need to use the word perpendicular. Okay, that is found on mark schemes, and examiners do want to see it. It is not sufficient to say they oscillate up and down or at right angles direction of travel. We have to say perpendicular. And once again, we've said what kind of wave it is and the direction it is. Running out of space. That will pick us up another 2 marks, giving us 4 marks in total. So let's move across to part B. For part B, the period of the sound waves produced by the motor is 8.3 milliseconds. Calculate the frequency of the sound waves. Use the physics equation sheet. So on the physics equation sheet, this year you're going to get given all the equations. And the one we're going to be looking for is time period, sometimes just written as period, is equal to 1 divided by the frequency. Running out of space again. Okay, now this is worth 3 marks. And this is a fairly straightforward question at first, so it's not always clear why it's worth 3 marks. But if you look closely, you will see it says 8.3 milliseconds. Now, milliseconds is not a standard unit. The standard unit for time is seconds. So we need to change that into seconds. How do we do this? Well, milli means 1,000 sol. It means we divide it by 1,000. So if we think of a millimeter, that's 1,000 times smaller than a meter. So a millisecond is 1,000 times smaller than a second. So if we divide this by 1,000, we're going to get 0.0083. Is that right? Yeah. Seconds. Okay. Doing that is worth 1 mark. If you don't do this, but do the next 2 stages correctly, you can pick up a maximum of 2 marks. This is always worth 1 mark. And every year there are students who miss this out and miss out the marks that are available for converting units. And even if you have no clue what you should be doing on a maths question, if you see something like this where we've got a non-standard unit, you can pick marks up just by converting it. So how are we going to use it? Well, we're going to put our numbers into our equation. We've been asked to find the frequency. Now, frequency is here, so I'm going to put this into my equation sheet. So into my equation, which equals 1 divided by f. Okay, now I want to get f on its own. I need to rearrange this. This is just basic algebra that we've been doing throughout our school career. So I'm just going to do 1 divided by 0.0083, which is going to give us the answer of, I'm going to need my calculator for this. So if we do 1 divided by 0.0083, that is going to give us 120.48 hertz. And the unit is already given to us in this instance. So our final part is a 6-mark question. Explain how the student could make appropriate measurements and use them to determine the wavelength of the waves in the ripple tank. So this is where we need to know our required practical method. So let's start by thinking about what kind of things we could do to measure wavelength. So wavelength is the distance between two peaks. So if I draw a quick transverse wave here, this distance between two peaks is our wavelength. And if we look on our diagram, we can see projected onto the bottom is our wavelength. We've got the peaks and the troughs projected there, so we could actually very easily measure them. But the problem is, in this, we've got a motor causing those waves to move, so we can't very easily measure the wavelength. So what are we going to do? Well, if you look on your wave equation sheet, you can measure wavelength by using our wave equation. So we can do wave speed divided by frequency, which will give us the wavelength. How do we get these measurements? So first we say we can use our wave equation, and we're going to quote the equation. V equals F times lambda. Lambda is the wavelength. Okay, it's a Greek letter L. Frequency. So frequency can be measured by counting the number of waves past a point in a set time. We can then divide by that time to get the number of waves per second. So waves per second is just frequency. That's what the Hertz unit is. It is just per second. Okay, flip over to random space. So to measure wave speed, we can just measure the speed the same way we measure the speed of anything. So we can measure the distance traveled. So measure the distance traveled. I'll say I'm using a ruler. Always be specific. And the time taken for a wave to travel I really should have pre-recorded this and done the audio later so I could speed it up. Oh well. So the time taken for a wave to travel from one side to the other then we can use speed equals distance divided by time to determine wave speed. So we've given two methods